Hello students, today we are going to discuss the various string manipulation instructions. We will understand the function of each instruction and also solve some programming questions. So let's begin. First, let's go through the various prerequisites for understanding string related instructions. The first point being, strings are basically stored as an array. Hence, we need two things for string processing. The first is your starting address, or we can say the end address of the string, and the second being we need to know the length of the string. So as mentioned before, the strings are stored as an arrays. So for an array, either you need the start address or the end address as well as the length of the array. So likewise, the same thing applies for the string also. The second point which needs to be understood is, so this is your point number 1. Okay. Now the second point, which is very important, the length of the string is stored in the count register. Okay. So the length of the string is stored in CX register. And coming to the third point, the registers used to generate the physical address of the strings are DS in couple with SI and ES in couple with DI. So we know that for 8086 there is a concept of physical address. So for physical address we need a segment register as well as an offset or index register. So here DS is used, the data segment register is used in couple with source index register, and the extra segment or the ES register is used with your destination index or DI register. Coming to your point number 4, the index register SI or DI are incremented or decremented depending upon the value of DF. So if you recall, DF stands for direction flag. Now if DF value is 0, that means auto increment takes place, whereas if DF value is equals to 1, then auto decrement will happen. So whether the index registers needs to be incremented or decremented depends upon the value of your direction flag. The fifth point here is the strings can be represented either in byte or in case of 16 bits it will be word. So strings can be represented either in byte or in word. So we know that 1 byte is 8 bits and 1 word is 16 bits. Now accordingly, whether the string is represented as byte or word, the index registers are incremented by 1 in case of bytes and by 2 in case of word. But the point to be noted here is the counter value which is stored in CX register is only decremented by 1. This will become more clear when we do some programming question. So before we jump to the instruction, let us now try to understand what we mean by byte or word size string. You can visit the website rapidtables.com. The link will be provided in the description. So in this website you can very well convert a text, it is a string, to any form of code like ASCII code, UTF code, etc. So let us see how does it works. So suppose I type here hello world. Now here it is provided as character encoding. So I select, there are various character encoding provided. Let me just select the basic one, that is your ASCII, and click on convert. So here as you see, each of these characters, that is HELLO, is getting converted to an equivalent hex code, which is an equivalent ASCII hex code. So H corresponds to 48 and E corresponds to 65 and so on. And this 5 symbols corresponds to the 5 letters HELLO. The space is represented by 20, and then we are having the word represented by again 5 sets of values. Now if we change the character encoding, what we find here is, suppose let me go to UTF-60 and again click on convert. Now we see the numbers doubles almost. So here H is represented by not 48 as in the previous case, but 4800. E is represented by 6500 and so on. So you see here double L, so double L is represented as 6C00, 6C00. So if you notice, all these are in hexadecimal values. Now if you see in the previous case ASCII, each of this 48, 65, 6C, they will occupy 1 byte, or that is 1 memory location. The basic memory unit size is 1 byte, which we have already discussed, and so each of these symbols, that is 48, 65, will occupy 1 byte space. Whereas if we are going for UTF-16 encoding scheme, each letter, that is H, will occupy 4800, that is 2 bytes or 1 word. So this is what we mean by whether it is a byte size string or a word size string. Now whether it is byte or word depends upon the which character encoding is adopted by the software. Now that we have gone through the basic concepts related to strings, let's now move on to the instruction set. First instruction is REP, which stands for repeat. Please note that it is not a standalone instruction but used as a prefix along with other instructions. So it is better to write as it is called REP, stands for repeat instruction prefix. Okay, so it is used along with other instructions. Now REP instruction repeats the instruction to which it is prefixed until the CX register becomes 0. So please note, the CX register, until unless it becomes 0, or I can write equals to 0, the repeat instructions repeats the instruction to which it is prefixed. Now REP has two variants, which can be stated as REPE, also called as REPZ, and then another one is REPNE or REPNZ. Now what are these two instructions? So REPE stands for repeat while equal, and or we can write repeat while 0, and REPNE is repeat while not equal or repeat while non-zero. Currently I am not going into much details about REPE or REPNE because these two instructions can be better understood while doing programming questions. So let us move on to the next instruction. The next instruction is MOVSB or MOVSW. We have already seen during the data transfer instruction move. Now move is used to transfer a data. Here data means numbers, but for the string it is MOVS, MOVS. Now whether the string is a byte size or word size, depending upon that we are having two instructions, MOVSB or MOVSWord. So if the string is a byte size instruction, we will be using MOVSB. If a string is a word size instruction, we will be using MOVSW. Now when we need to move a string from one location to another, we need a starting address and a destination address. Okay, so usually move happens from a source location to a destination location. So starting address is given by DS and SI. So we have already seen DS stands for data segment and SI stands for source index. So source index will act as your index or offset register. For the case of destination address to which the string has to be moved, this address is given by ES and DI, where ES stands for extra segment and DI stands for destination index. After this instruction is executed once, that is if MOVSB is executed once, the CX is automatically decremented and the index registers are automatically updated. Okay, so CX, that is the count register, will be decremented only by 1, whereas the index registers are automatically updated. Now when I am saying updated, it does not always mean that it will be incremented by 1. Okay, so it depends whether you are using MOVSB or MOVSW. So if your direction flag is set to 0, okay, so if your direction flag is set to 0, that means we know that it is auto increment mode. If earlier your source index value was 5000, okay, and the MOVSB instruction is executed, and we know that it's a MOVSB is a byte size instruction for the move part, so SI will get incremented to 5001. Okay, whereas if it would have been a word size instruction, your SI for word size, the SI will get incremented by 2, so it will become 5002. Whereas after execution of every move SB instruction, the count value will only be decremented by 1, which we have said it before. Now what we'll do is, now let us go through some programming question to get more clarity for the things which have been discussed up to now. Our first question is, write an 8086 assembly language program to move 10 bytes of string data where the source segment is 4000H and index 2000H and the destination segment is 8000H and index 6000H. Now from the given question, first let us write what has been provided to us and then we will proceed towards the programming. So given here, it is already mentioned 10 bytes of string data. So first thing is we have to deal with string instructions and it is given 10 bytes. Now this conveys two information. First is it's a byte size string. Byte size string. The length of the string is 10 bytes. So this value we need to store in CX register. Okay. The next part, the source segment is 4000H and index is 2000H. Now as we have just now discussed, for the move instruction, the source location is given by DS and SI and the destination is given by ES and DI. So we have to load the value DS as 4000H and SI as 2000H. Then ES we have to load 8000H and DI as 6000H. So these are the values for which we have to write the program. Now what we will do is, let me just show you how the memory map will look like. So since this is the first question related to strings, I will just proceed by memory map way and then we will proceed towards writing the 8086 program. So as you can see here, I have made this memory map where the source address with respect to DS and SI is given like this and destination address ES and DI is given like this. Now the content here is hello world, which we have already seen. So HELLOWORLD. I have just left out the space between hello and world to make it 10 bytes, and this example will try to understand how the programming will happen for this. Now the data which is there as 42000H needs to go to 86000H. So this data has to go here. Likewise, one-on-one mapping needs to be done. So all the data at the respective location, so 42000H needs to go to 86000H and likewise 42009 needs to go to 86009. So how we will start programming? So if we start our source location from 42000H and we start moving 1 byte of data to 86000H, we are going in increment mode. So the direction flag has to be set to 0. Okay. If we would have started in other ways, like if you would have given the start location as 42009 and the destination location as 86009, so here it will go in auto decrement mode. Okay. And in this case the direction flag will need to be set to 1. So now we are clear that since the source index value is given as 2000, so we have to go in auto increment mode. So the value of the direction flag in this case will be 0. So let us move to our program. Now we can write here the given value of direction flag will be 0. Before proceeding towards the instruction sets of assembly language program, we should always remember that the segment registers cannot be loaded directly. So we cannot write this instruction move ds, 4000H. Okay, so this cannot be written. This is wrong. Okay, now for this what we need to do is we have to use a general purpose register and then we have to load the value into the general purpose register and from the general purpose register into the segment register. So let us start writing our program. So first instruction will be move AX, 4000H. So this moves the content AX. So here AX equals to 4000. Then move ds comma ax. So this gives the content of ds, content of ax. Next we have to load the value of es, so we'll proceed with the same way. So content of ax is 8000h. You can comment it accordingly. Okay, I am not providing the comments for that now. Move es comma ax. So we have loaded our segment registers. Now what we'll do is we will load our index registers. So move si comma 2000h move di comma 6000h. Okay, after that we have to load our count register, which is cx. So what we can write, move cx comma 10. Now 10 bytes. Now we need to convert this into hexadecimal. So that equivalent is 0ah. After that we need to ensure that our direction flag is cleared. So for that we are having an instruction cld, which means clear the direction flag. Okay, so cld stands for clear the direction flag, std stands for set the direction flag. So this instruction till now we have not yet covered, but since it was needed here, so that's why I have introduced this instruction cld. Okay, after this we have to ensure that from the source segment the data moves to the destination segment. We will not be writing move sb 10 number of times. Instead what we can use the command REPE move sp. Now what this instruction will do is, as I have already mentioned, this REPE instruction acts as an instruction prefix. Now since it is acting as an instruction prefix, it will execute move sb that many times until and unless the count value, that is cx register, becomes 0. So this will happen only when your entire data of 10 bytes get transferred to your destination segment. So I hope you are clear with this programming example. Now let us move on to the next instruction. The next instruction is CMPs, that is compare string. You are already aware of CMP instruction, which we have seen in arithmetic instruction set. Now CMP instruction, it compares the two instructions, that is it does a virtual subtraction without affecting the contents of the source and destination. Okay. Likewise, the compare string instruction stands for CMPs, and it compares the source and the destination string without affecting both the source string as well as the destination string, and the only thing which gets changed or which gets affected is your flags. So if both the strings are equal, then the 0 flag will be set to 1. If it is not equal, the 0 flag will be set to 0. Now this CMPs instruction has two variants. One is CMPs B, which compares byte size string, and the another one is CMPs W, which compares word size string. This instruction compares two strings byte by byte or word by word, and if both of them are equal, then the 0 flag is set, because it basically subtracts the hexadecimal value of the destination from the source. This byte by byte or word by word comparison, depending upon which one is used, CMPs B or CMPs W, this thing continues till a mismatch is found. Now let's do one programming question related to this instruction. So the question is, write an 8086 assembly language program to compare 10 sets of word strings where the source segment is 4000h and index starts from 2000h, and the destination segment is 8000h and the index starts from 6000h. The program should stop when a mismatch is found. So again, like we have done the previous programming example, let us write what are the given things to us. So we have to compare 10 sets of word strings. So the CX register will contain 0A, okay, so 10 in hexadecimal is 0AH, okay, and here it is word string. So please remember, we have to use which instruction? CMPSW. Okay, so we have to compare, and that is why we need to use CMPSW. And the source and the destination segment is, so DS will contain the value 4000H, and for that the index, now see here, the index starts from 2000H. So here it is saying that it is starting from 2000H, so we have to make the direction flag as 0. Okay, so DS equals to 4000H, and SI, that is your source index, is 2000H, so ES equals to 8000H, and DI equals to 6000H. Also we know that the content of direction flag equals to 0, so we have to use the CLD instruction again. Now what we'll do is, again we'll go to the memory map and try to see how the locations as well as the memory addresses and the content will look like by an example. So here we are having a memory map where the source location pointed by DSSI and the destination address pointed by ESDI is given. So I have taken the same string hello world, and which has a corresponding ASCII equivalent which is located in this memory location, and there is a destination address which contains the same hello world, but it is not world but it is word. So here we are having a mismatch at this location. So your string comparison will go on from 42,000 and 86,000, and it will keep on going till a mismatch is found, which is at 42,008H and 86,008H. Okay, so from here onwards, or at this location, the repeat instruction will break off. Okay, so this we have to write a 8086 assembly language program. So let's start. Alright, so now coming to the program, if you notice, in the previous example we have used the same set of data for the source index, destination index, source segment, and the destination segment, as well as the count value was same. We only need to modify one line. So what I'll do, I'll just copy paste the instructions which we have used for the previous example. So this is the set of instructions. Now up to here everything is as per the given data. After this we need to write REPE CMPSW. Now let us understand what happens here. Here we will be using REPE instruction. Now REPE stands for, let me write here, REPE stands for repeat while equal or 0. Okay, or REPZ. So I could have written REPE or REPZ, both the things mean same. So repeat while equal or 0. Now this instruction is used because the CMPSW must repeat until and unless a mismatch is found. Okay, so I hope you are clear with this programming solution, and now we'll be moving to the next instruction, which is SCAS, which stands for scan string. Like other instruction, it has two variants, SCASB and SCASW, depending upon whether it is a byte string or a word size string respectively. This instruction is used to scan a string for an operand byte or word which is specified in AL or AX register. So if a byte has to be scanned, it will be stored in AL register. Okay, so if a byte needs to be scanned, it has to be stored in AL register. If a word needs to be scanned, it will be stored in AX register. And the string is pointed by ES and DI couple, the register pair, and the length is stored in CX register. So I had mentioned the string contents is pointed by ES DI register pair, and the count value or the length of the string is in CX register. Let us understand this example also by means of a programming question. So in this question, it asks write an 8086 assembly language program to find whether the character R, okay, whose ASCII value is 72H is present in the string whose source segment is 3000H and index starts from 5000H. The length of the string is 10 bytes. So let us first write what are the given things. So given the content which needs to be found out is R, okay, and whose ASCII value is 72H. So as you see, it's a byte which needs to store it into AL register. So AL content we should store as 72H, okay, and here the string whose source segment is 3000H and index starts from 5000H. Now as we have discussed in the scan string, the source segment is pointed by ES register. So extra segment has 3000H as value, and let me put here square brackets, okay, and in the destination segment we have 5000H. Again it is provided in the question index starts from 5000H, so we have to make direction flag equals to 0, so we'll be using CLD instruction, okay. The length of the string is 10 bytes, so CX register contains 0AH. So let me again explain it to you by means of a memory map. Okay, so here the memory map is present. Now please note I have written in red letter that for the scan string we have to use ES and DI, not DS and SI. Okay, this is a very important point. For the scan string instruction, the ES and DI points to the string. So the same example, hello world, and we have to scan for a letter R which is located at this location 35007. Now the scan string can only be used for one memory location. If you want to repeat it 10 times, we have to use a variant of repeat instruction. So now let us go back to the programming part and understand how it will be used. We have come across three variants of REP instruction. One is REP, another is REPE or REPZ, and the next one is REP and E or REP and Z. Now in this question, please note we have to find whether the character R whose ASCII value is 72H is present in the string or not. So what do we need to do is we have to use SCASB instruction that many times until and unless this character R is not matched with that string. Okay, so we have to keep on repeating it until and unless we don't find it. So until and unless it is not equal. So which instruction you will use? I would suggest that I have given subtle hints for you to complete this program. Therefore I will look forward that you can complete this program and mail it to me or submit it in the comments, and then I will have a look and let you know if you go somewhere wrong. Alright, so now let us move to the next instruction is LODS, which stands for load string. So we have seen earlier also that the load operation transfers a set of data from the memory to the register, whereas the store operation does the opposite. So it transfers the data from the register to the memory. Now in the case of load string, that is LODS, the string is located in the memory which needs to be transferred to the internal registers. So the source memory location is given by DS-SI register pair, and the content from the DS-SI register pair will go into a destination register which is AL or AX. Now why AL or AX? You would have guessed it. So LODS has two variants, LODS-B and LODS-W. So if it is a byte size string, then it will move to AL. If it is a word size string, it will move to AX register. Alright, so let us take an example. Suppose the content of DS and SI is given as 4000 is to 5000. Okay, so what is the physical address? So it will give 45,000 H. Now, and let us consider the content at 45,000 H is 72 H. So if LODSB instruction is executed, then the content of AL will become 72H. Okay. So likewise you can also frame an example for load as word. Now let us move to the next example. Okay, before moving to the next example, what I'll do is, we have another point to be noted here is, if load SB is used, then a byte is copied to AL and SI is incremented by 1, because it's a byte size. So after one memory location hold 1 byte, so once 1 byte is transferred, the index register will get incremented by 1. If load SW is used, then a word is copied to AX register and SI is incremented by 2. Okay, so this point should be noted. This also happens in the move instruction or scan instruction, whether you are using SB or SW, and the increment of the index register takes place by a factor of 1 or 2. Okay, the same thing is applicable to your load instruction also. Now let us move to the last instruction, which is your store instruction. STOS stands for stored string, and here the string which is already present in AL or AX register, the contents of which moves to a location to the string pointed by ES and DI register pair. So here the string is already present in AL or AX register depending upon byte or word, and it is moved to, so the destination string location is given by ES DI register pair. Fine. This is similar to loads, but in a reverse way. As we have already discussed, in the case of store, the data moves from the register to the memory. Okay, so in the case of store string, the string is already present in your register and it moves to your memory location. But here the difference is, the destination string location where the data has to be moved is pointed by ESDI register pair. And as you would have guessed, here also you are having two variants, STOSB and STOSW, depending upon whether it is a byte size or word size string. With this, we finish the string manipulation instructions and we move on to the control transfer instructions. Though at first glance it looks too many, but if you have understood few of them, then the rest of them is quite easy to follow. These instructions will be discussed in the next video.